So a definition, a differential equation is an equation involving some unknown function y and one or more of its derivatives. And in this case, notice I just give an example, y double prime plus y equals 3. That certainly satisfies that definition. I have a second derivative of y as well as y present in that equation. And so what I want to talk about now are some other terms related to these differential equations, such as the order of a differential equation, whether a differential equation is linear or nonlinear, and whether it is ordinary or not. So I want to talk about those terms with some examples. So that example that we just looked at, y double prime plus y equals 3, would be a second order linear ODE. ODE stands for ordinary differential equation, and that's notation that you'll see, an abbreviation that you'll see in the book is ODE. And so second order, the highest derivative that you see in the equation is the order of the differential equation, much like the highest power that you see in a polynomial refers to the degree of the polynomial. It's the same idea here with the differential equation, but now it's the highest derivative that you see is the order of the differential equation. And notice I've said this is a linear differential equation. That's because all of the coefficients of the terms that you see, including the term to the right of the equal sign, are functions of the independent variable only. Say I'm using t as the independent variable. In this case, notice they're all just constants. But so that's linear. The term ordinary refers to the fact that there is only one independent variable in the equation, not more than one. And that's the case here, and that's why this is an ordinary differential equation. I give you another example below. Notice, remember, when we go to the fourth derivative, we go to Roman numerals because we don't want to keep writing all the primes. And so here, since that fourth derivative is the highest derivative that I see in the problem, it's a fourth order. Again, notice linear because my coefficients are all functions of the independent variable only. I don't see the dependent variable y in there at all as a coefficient. And again, only one independent variable, t, so that is why it's an ordinary differential equation. So now I'll give you a couple examples of a nonlinear and also what it would mean to not be an ordinary differential equation. So notice at the top, y double prime plus y squared times y prime plus 4y equals 7y cubed. And notice that this is a second order because that second derivative is the highest power that we see, the highest derivative rather that we see there. And notice it's nonlinear because instead of being functions of the independent variable t, I have a coefficient here that is a function of the dependent variable y. And similarly on the right hand side here with that 7y cubed. Notice down below, y triple prime plus u squared v y prime equals u squared v cubed. I now have two independent variables, u and v. When that happens, it is not an ordinary differential equation. Third order, but not ordinary. There can only be one independent variable in order for it to be ordinary. If you have a function with more than one independent variable, or an equation, I should say, with more than one independent variable, you would deal with that in a partial differential equations course. But all of the differential equations that we're going to be looking at in this course are going to be ordinary. So I just wanted you to have that terminology regarding the order, whether it's linear versus nonlinear, and also ordinary versus not ordinary. So those are some terms that you'll see, and that abbreviation ODE that you'll encounter in the text, meaning ordinary differential equation.